Hello everyone, I am Rama Bharati, Assistant Professor, ECE Department from SNS College of Engineering. So in our last video, we discussed about what is multitasking multitasking in RTOS, and in this video, we are going to discuss about scheduling in RTOS multitasking. So that scheduling, it is in different types or different ways we have scheduled the multitasking. So the three scheduling that are priority based preemptive scheduling, round robin and event driven. So first we will discuss what is priority based preemptive scheduling. So in priority based preemptive scheduling, it gives the importance to the highest priority process. So first it starts the execution for the highest priority task. Once it processed executing, the new task will enter into it with the highest priority than the executing task. It preempts the execution and start execution with the new task. So it is called as priority based preemptive scheduling. The next one is round robin. So in round robin, first all the tasks are assigned in a queue. And assigned in a queue, each task or each process, it assigns a time for executing and start the execution with the first process in the queue. So while executing in that, it completed that execution within the predefined time. So it starts the execution with the next one. Suppose otherwise within the allocated time it doesn't complete the execution, means it put the particular task into the end of the queue and start the execution with the next task. So likewise the cycle will continue and it complete the process until all the process will complete the execution. So it is in round robin mechanism. So equal priority task will given in that share the CPU time. It is called as round robin. Then third one, that is event driven mechanism. So here flow of program execution is determined by the events. So here several events we have, that is a press button, a temperature threshold being crossed, network message arriving and hardware interrupt. These are the events. Here it have three states to the process. First one, that is idle state. So it is idle until event occurs. Then second one, event detection. System receives any event handler start the execution. So it handle the specific event and complete the event execution. Then finally return. Once handled that, it returns to the idle state. It is explained in that event driven mechanism. So these three are the scheduling in RTOS multitasking. Then next one, interrupt handling in multitasking. So interrupts, asynchronous events require immediate attention. So here we have ISR, that is interrupt service routine. It handle interrupt with highest priority. So the interrupt handling in multitasking also depends on the scheduling of multitasking. So this impact of this interrupt handling mechanism, it preempts the task and affecting scheduling. Then task synchronization mechanism. In task synchronization mechanism, we use three components. One is semaphores, mutexes and queues. Semaphores, it control the access of shared resources, and mutexes, it prevent concurrent access to the critical sections. Message queues, it enable intertask communication. So these are the task synchronization mechanism. Next, memory management in RTOS. So here both memory allocation will possible, static allocation and dynamic allocation. Static allocation mainly for a fixed memory assigned at design time, and dynamic allocation, it's a runtime allocation. So mainly dynamic is more powerful because it is a user friendly. We can high speed purpose we can use a dynamic, but in multitasking RTOS it prefer only static allocation. It avoids dynamic allocation for predictability. Then next, applications. So applications of RTOS multitasking, several applications we have: automotive, aerospace, medical, IoT. So most of all real-time applications are the example of RTOS multitasking. And automotive airbag system, engine control units. In aerospace, flight control systems. In medical, pacemakers, infusion pumps are the examples. And IoT, smart sensors and wearable devices are the example of RTOS multitasking. Then what are the challenges we face in the RTOS multitasking? First one, that is priority inversion. We all know that it's a preemptive scheduling we use, so we'll give importance to the highest priority things. So lowest priority task delay high priority ones. So it is called as priority inversion. It is the main drawback or challenges we face in multitasking. Next one, deadlocks. Task wait indefinitely for resources. So the time will lag in that multitasking. Then jitter, variability in task execution time. So each task it have several execution time. So to overcome that, we'll use a round robin mechanism, but also it is a very challenge one in RTOS multitasking. Thank you.